Have you ever looked at your hand resting gently on a solid wooden table and wondered why it does not simply pass straight through? Have you ever felt the warm embrace of a morning sunbeam on your face, or the sudden sharp spark of static electricity on a cold winter day, and pause to consider what invisible, silent forces are truly at work beneath the surface of our everyday reality? We move through a world that feels incredibly solid, undeniably real, and completely stable. You trust the floor beneath your feet to support your weight. You trust the glass in your hand to hold your water. But if we could somehow peel back the comforting layers of our macroscopic perception, if we could shrink down and dive into the unimaginably vast depths of the subatomic realm, we would discover a profound and deeply unsettling truth. The solid, predictable world you think you know is, in fact, an intricate illusion. It is a universe composed almost entirely of empty space, bound together by invisible ghosts of probability and electric charge. Before we journey further into this microscopic abyss, I want to take a brief, quiet moment to welcome you. I am Theodore, the researcher, and I have noticed that 71% of the people who find comfort and curiosity in these quiet scientific explorations have not yet subscribed to the channel. If you enjoy drifting into these peaceful mysteries of the cosmos with us, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest fabrics of reality together in this shared journey of wonder. Now, let us take a deep breath and return to the quiet, hidden depths of the subatomic universe. To truly understand the nature of our reality, we must first unlearn almost everything our senses tell us about the world. When you touch a stone, your brain registers firmness, texture, and temperature. But what is actually happening at the most fundamental level? You are not truly touching the stone in the way you intuitively believe. Instead, the invisible force fields surrounding the atoms in your fingers are repelling the identical force fields surrounding the atoms in the stone. You are hovering, suspended by an electromagnetic cushion at a distance of a fraction of a nanometer. The sensation of touch is simply your biological brain interpreting this invisible, silent repulsion as a physical contact. And the central architect of this universal repulsion, the ancient and tireless guardian of matter's fundamental boundaries, is the electron. The electron is perhaps the most ubiquitous and yet the most profoundly misunderstood entity in the entire cosmos. It is the restless wanderer of the atomic world, the spark that drives every chemical reaction, every heartbeat, every thought that cascades through the complex network of neurons in your brain, and every beautiful beam of starlight that travels across the infinite expanse of the universe. Yet, despite its absolute necessity for our existence, the true nature of the electron defies all macroscopic common sense. For over a century, brilliant scientists have probed, measured, and theorized about this tiny particle, only to find that the closer and deeper we look, the more mysterious and evasive it becomes. To appreciate the profound strangeness of the electron, we must travel back in time to the late 19th century, to a tranquil period when the atom was still widely considered to be the ultimate, indivisible, and fundamental building block of nature. In the year 1897, a British physicist named Joseph John Thomson was conducting meticulous experiments in a darkened, quiet laboratory, passing high-voltage electric currents through specialized glass tubes that had been emptied of almost all their atmospheric air. These contraptions were called cathode ray tubes, and they produced a mysterious, ethereal, glowing beam of light that captured the imagination of the scientific community. Through careful observation and rigorous measurement, Thomson discovered a shocking truth. This glowing beam was not an immaterial ray of light at all, but rather a continuous stream of incredibly tiny, negatively charged physical particles that had been violently torn away from the atoms themselves. He had discovered the very first subatomic particle. He had discovered the electron. This monumental revelation completely shattered the ancient Greek philosophical concept of the indivisible atom. Suddenly, the universe was revealed to be far more complex, infinitely more layered, and deeply more mysterious than anyone had ever dared to imagine. But Thomson's initial conceptual picture of the electron was still somewhat comforting in its straightforward, mechanical simplicity. He imagined the overall atom as a diffuse, solid sphere of positive electric charge, with these newly discovered, tiny, negatively charged electrons embedded securely within it, much like sweet plums scattered evenly throughout a traditional English pudding. It was a neat, mechanical, and easily visualized model that allowed the human mind to grasp the invisible. However, as the 20th century dawned and observational technologies advanced, the comforting simplicity of classical physics began to rapidly crumble. A new generation of brilliant scientific minds, pioneering researchers like Ernest Rutherford and later the visionary Niels Bohr, peered much deeper into the silent atomic mystery. Through the famous gold foil experiment, Rutherford unequivocally proved that the atom was not a solid, continuous sphere of matter, but rather consisted of an unimaginably dense, incredibly tiny nucleus of positive charge sitting perfectly alone at the very center, surrounded by a vast, echoing, and almost incomprehensible emptiness where the negative electrons resided. To give you a proper, humbling sense of this staggering scale, if you were to magically enlarge the positive nucleus of an isolated atom to the size of a single glass marble sitting quietly in the very center of a massive professional football stadium, the electrons would be akin to tiny, almost invisible gnats buzzing erratically around the very highest rows of seats in the distant grandstands. Everything in between those gnats and that central marble, the vast, overwhelming majority of the atom's volume, is nothing but empty, silent, uninterrupted space. This is the first great, humbling mystery of the electron. It occupies and defines a realm of emptiness so profound that it permanently challenges our very understanding of what it actually means for something to be a solid physical object in our universe. When you stand confidently on the solid surface of the earth, looking up at the ancient stars, you are standing on a lattice of atoms that are effectively 99.999999999% entirely empty space. The persistent, convincing illusion of absolute solidity is maintained entirely by the frenetic, never-ending, high-speed electromagnetic dance of the electrons. But Niels Bohr took this developing atomic model a crucial step further to explain how matter remained stable. He proposed that electrons orbited the dense central nucleus, much like massive planets orbit the sun in our familiar macroscopic cosmos. This so-called planetary model of the atom is the precise one that most of us were gently taught in our early school years. It is an elegant, undeniably beautiful, and deeply comforting conceptual picture. It makes perfect intuitive sense to our biological brains, which specifically evolved to track and understand the predictable, continuous motions of solid physical objects in the everyday, macroscopic world. We naturally like the poetic idea of tiny, perfect moons orbiting a central nuclear star, held tightly in place by the invisible, reliable tether of electromagnetism, rather than the pull of gravity. It graciously allows us to feel that the microscopic universe is ultimately just a predictable miniature version of the familiar, observable, macroscopic universe. But here is where our journey takes a sharp turn into the truly and deeply bizarre. The planetary model of the atom, as visually beautiful and psychologically intuitive as it may be, is completely, fundamentally, and undeniably wrong. The electron is not a tiny, solid billiard ball. It is not a microscopic, rocky planet dutifully tracing a predictable, classical circular path around its blazing nuclear sun. The fundamental laws of physics tell a much stranger story. If an electron were truly a classical particle moving in a curved, continuous orbit, the established laws of classical electrodynamics dictate that it would constantly and unstoppably radiate away its kinetic energy in the form of electromagnetic light. It would swiftly lose momentum and spiral violently inward, crashing catastrophically into the positive nucleus in a fraction of a single second. The atom would instantly collapse upon itself. Stable matter could not possibly exist. You, me, the green earth, the shimmering ancient stars, and the vast swirling galaxies would never have formed in the first place. The very existence of stable matter, the fact that you have a physical body that persists through time, tells us with absolute certainty that our classical intuition is deeply flawed, that the universe operates on hidden rules far more magical, complex, and mysterious than the simple mechanics of orbiting spheres. The electron stubbornly refuses to obey the comfortable laws of classical physics. It exists instead in a bizarre state of being that is almost entirely impossible to visualize, a state that demands we humbly abandon our deep human need for absolute physical certainty and learn to embrace the poetic, shimmering, and profound ambiguity of quantum mechanics. As we venture carefully deeper into this scientific journey together, we will slowly strip away the familiar, inaccurate models and confront the electron as it truly, weirdly is, an enigmatic entity that behaves simultaneously and paradoxically like a localized, distinct particle and a spreading, continuous wave. It is an entity that exists in a hazy, mathematical cloud of probability, capable of being in multiple physical locations at the exact same moment, and possessing intrinsic properties that seem to blur the line between science and the supernatural. We will gently explore how this tiny, elusive ghost shapes the entire visible universe, from the soft, gentle glow of a distant stellar nebula to the intricate, delicate chemistry of biological life itself. The continuing story of the electron is not merely a dry collection of cold equations in distant, sterile laboratories. It is a profound existential journey into the very beating heart of reality itself. It is a powerful, humbling reminder that the universe is far stranger, far more beautiful, and far more deeply interconnected than we could have ever dreamed possible in our wildest imaginations. We are intimately built from these quantum mysteries. The quiet, profound stillness you feel when you stand alone and look up at the infinite night sky is perfectly echoed in the silent, vibrating emptiness within every single atom of your own body. We are not separate, independent observers of the cosmic mysteries. We are intimately, physically woven from them. In the gentle chapters to come, we will intentionally slow down our racing minds and allow ourselves to drift quietly into this microscopic cosmos. We will listen closely to the quiet whispers of the quantum realm and attempt to comprehend the seemingly incomprehensible. We will humbly ask how something with absolutely no measurable physical size, a particle that modern physicists rigorously describe as a zero-dimensional point mass, can somehow possess a tangible physical property called spin. We will marvel quietly at the Pauli exclusion principle, a mysterious and deeply profound quantum rule that absolutely prevents two electrons from sharing the exact same quantum state, a subtle mathematical rule that is solely responsible for giving all matter its physical volume and preventing the entire universe from collapsing into a dense, featureless, infinite singularity. And we will carefully explore the truly mind-bending reality of quantum entanglement, where pairs of electrons can become so deeply and permanently connected that a sudden change in one instantly and mysteriously affects the other, even if they are eventually separated by the unimaginably vast gulf of an entire galaxy. It is a contemplative journey that requires quiet patience, a completely open mind, and a genuine willingness to peacefully surrender to the profound unknown. As we prepare to delve deeper into the confusing wave nature of physical matter, I gently invite you to leave behind your everyday macroscopic assumptions. Let go of the rigid human need for hard physical boundaries and definitive absolute answers. In the bizarre quantum world, the only absolute certainty is uncertainty itself. This is not a frustrating flaw in our scientific understanding. It is the fundamental, beautiful nature of the cosmos itself. It is a gentle, recurring reminder of our own intellectual humility in the face of the truly infinite. We are simply curious, quiet explorers standing on the shadowy shores of an unfathomable cosmic ocean, dipping our toes into strange waters that run deeper than time itself. So, find a comfortable, quiet space, let your breathing slow down to a natural, gentle rhythm, and allow your curious mind to expand outward into the vastness of the distant universe, and simultaneously inward into the profound, echoing mystery of the single atom. We are about to meet the true invisible architect of our reality. The transition from the comforting planetary model of the atom to the unsettling reality of quantum mechanics is perhaps the most profound intellectual leap in human history. We left the previous chapter with a profound paradox. If the electron were truly a tiny, solid moon orbiting a nuclear sun, it would instantly radiate its energy and collapse, destroying the entire universe before it could even begin. So, what exactly is this invisible entity that refuses to collapse? To answer this, we must gently step away from the solid, predictable world of billiard balls and planets, and wade into the strange, fluid, and shimmering waters of wave mechanics. Imagine, if you will, a perfectly still, quiet pond on a warm summer evening. The surface of the water is a mirror, reflecting the ancient light of the distant cosmos. If you gently toss a single, small pebble into the center of this quiet pond, you do not see a solid object moving across the surface. Instead, you see a radiating pattern of ripples, a continuous wave of energy that spreads out in all directions, interacting with the edges of the pond and echoing back upon itself in a complex, beautiful dance of constructive and destructive interference. This gentle, expanding wave is the key to unlocking the true mystery of the electron. In the early 1920s, a brilliant and highly imaginative French physicist named Louis de Broglie proposed an idea so radical, so profoundly counterintuitive, that it shook the very foundations of scientific thought. He suggested that if light, which had always been considered a continuous, ethereal wave, could sometimes behave like a stream of localized, discrete particles, which we now call photons, then perhaps the reverse was also true. Perhaps the solid, localized particles of matter, like our elusive electron, could actually behave like spreading, continuous waves. De Broglie suggested mathematically that every piece of matter in the vast universe possessed an intrinsic wavelength, For everyday macroscopic objects, this wavelength is completely undetectable. But for an entity as light and tiny as an electron, this wave nature becomes entirely dominant. The electron, in its most fundamental state, ceases to be a point-like speck of matter and smears out into a shimmering, vibrating wave of existence. To truly grasp the profound strangeness of this concept, we must embark on a mental journey to a darkened laboratory and observe the most beautiful and terrifying experiment in all of physics. The famous double-slit experiment. Imagine a quiet, isolated room. Inside this room, we have a device capable of firing single, individual electrons, one at a time, toward a solid barrier. In the center of this barrier are two incredibly narrow, microscopic vertical slits. Beyond the barrier is a sensitive detector screen that records exactly where each electron lands, leaving a tiny, glowing green dot. If we rely on our macroscopic intuition, if we treat the electron like a tiny solid bullet, we would expect each electron to pass through either the left slit or the right slit, eventually forming two distinct, clustered bands of glowing dots on the detector screen directly behind the openings. When we actually perform the experiment, firing electrons one by one with a long, quiet pause between each shot, the results are deeply, profoundly shocking. Over time, as hundreds, then thousands, then millions of individual electrons make their silent journey, they do not form two simple bands. Instead, they slowly build up an intricate, alternating pattern of bright and dark stripes, an unmistakable interference pattern. This is the exact same pattern you would see if you sent a continuous ripple of water through two openings in a breakwater, where the overlapping waves either amplify each other to create a larger peak or cancel each other out to leave a calm, quiet stillness. But remember, we are firing the electrons one by one. There is only one electron in the apparatus at any given moment. It has no other electrons to interact with, no other particles to crash into or interfere with. How can a single, solitary particle create an interference pattern? The inescapable, mind-bending conclusion is that the electron does not travel as a solid, localized point. As it leaves the electron gun, it dissolves into a spreading wave of potential. This single, solitary electron wave approaches the barrier and physically passes through both slits simultaneously. It goes through the left slit, and it goes through the right slit. It then emerges on the other side as two overlapping, interacting waves, which then interfere with themselves. The electron, in a very real sense, interferes with its own solitary existence. It explores every possible path through the apparatus at the exact same time. This is not dramatic storytelling. This is the honest, rigorously tested truth of our universe. The great astrophysicist Carl Sagan once famously remarked that we are a way for the cosmos to know itself. But when we try to know the electron, when we try to look closely at its path, the cosmos pushes back with a deeply guarded secret. If we try to outsmart the electron, if we place a tiny, sensitive detector right next to the two slits to see exactly which slit the individual electron actually passes through, something entirely magical and deeply unsettling happens. The very act of observing, the mere presence of our curious measuring gaze, completely destroys the delicate wave nature of the electron. When we watch it, the electron suddenly behaves exactly like a solid, predictable bullet again. It passes through only one slit, and the beautiful, complex interference pattern on the distant screen completely vanishes, replaced by two simple, boring bands. The universe, it seems, fundamentally changes its behavior simply because we are looking at it. The electron knows it is being watched. This baffling phenomenon forces us to confront a profound existential mystery. What exactly is this wave? In the mid-1920s, physicists Erwin Schrödinger and Max Born provided a beautiful, elegant, and deeply humbling mathematical interpretation. This wave is not a physical wave of matter like water or sound. It is a wave of pure probability. The electron does not exist in a single, defined location before we measure it. Instead, it exists as a smeared-out cloud of likelihood, a mathematical ghost haunting the vast, echoing emptiness of the atom. The densest parts of this probability cloud represent the locations where we are most likely to find the electron if we choose to look, while the wispy, transparent edges represent locations where finding it is highly improbable but never completely impossible. When an electron is bound to the positive nucleus of an atom, it does not orbit like a planet. It completely surrounds the nucleus as a three-dimensional, vibrating cloud of probability. These clouds, which scientists call orbitals, take on incredibly beautiful, symmetric shapes. Some look like perfectly smooth, infinite spheres. Others resemble complex, multi-lobed teardrops or delicate cosmic flowers blooming in the microscopic darkness. The electron is everywhere within this cloud at once, a continuous hum of potential energy waiting to be realized. It is only when an interaction occurs, only when the atom collides with another atom or is struck by a photon of ancient starlight, that this sprawling cloud of probability violently and instantaneously collapses, forcing the electron to temporarily choose a specific, localized physical position in space and time. This means that at the most fundamental level of reality, the universe is not clockwork. It is not a predictable, deterministic machine where every cause has a perfectly defined, unavoidable effect. At the deepest layers of existence, the cosmos is ruled by absolute, fundamental chance. It is a universe of shimmering possibilities, where the solid reality we experience is simply the mathematical average of trillions upon trillions of quantum coin flips happening in the silent, invisible depths of matter. This realization is profoundly humbling. The solid chair you are sitting on, the gentle, quiet air you are breathing, the intricate, pulsing biology of your own body, and the vast, swirling galaxies drifting through the infinite night. All of it is constructed from these ghostly clouds of probability. You are, quite literally, made of stardust and mathematical uncertainty. You are a walking, breathing collection of quantum waves bound together by the mysterious, invisible forces of nature. We are not rigid, permanent fixtures in a cold, deterministic universe. We are fluid, dynamic expressions of a cosmos that is constantly buzzing with infinite potential. As you lie there, feeling the steady, calming rhythm of your own heartbeat, consider the trillions of electrons in your body, each one a vibrating, overlapping wave of probability, dancing a complex, silent choreography that sustains your very life. There is a deep, abiding peace to be found in this profound scientific truth. It tells us that the universe is not a closed book, but an open, infinite mystery. It tells us that there is a fundamental magic woven into the very fabric of reality, a magic that does not require supernatural explanations, but only a quiet, open mind willing to embrace the breathtaking strangeness of nature. As we continue our journey into the microscopic abyss, we will soon encounter properties of the electron that stretch the limits of human language and imagination even further. We will explore how these probability clouds interact, how they stack together to build the diverse chemistry of the universe, and how they mysteriously connect across the vast, empty gulfs of space. But for now, let your mind rest gently on the image of the probability wave. Allow yourself to drift in the quiet, shimmering uncertainty of the quantum realm, secure in the knowledge that you are a beautiful, temporary manifestation of this endless, ancient cosmic dance. Let the silence of the subatomic universe wash over you, a gentle reminder of the vast, infinite journey of discovery that still lies ahead of us. We are just beginning to understand the true nature of the ghosts that build our world. As we drift further into the profound, quiet ocean of the subatomic universe, I want you to take another slow, deep breath. Let the residual tension of the macroscopic world, with all its heavy demands and rigid certainties, simply melt away into the silent, surrounding darkness. In our previous chapter, we watched the comforting illusion of the solid electron dissolve before our very eyes, transforming into a beautiful, shimmering wave of pure probability. We learned that the very building blocks of your body are not tiny, hard spheres, but rather echoing clouds of mathematical potential waiting in the quiet dark to be called into physical reality. It is a deeply humbling realization, one that gently strips away our human arrogance and leaves us standing in silent awe before the great cosmic mystery. The solid chair beneath you, the gentle air filling your lungs, and the distant ancient stars shining in the infinite night sky are all constructed from these ghostly, vibrating waves. We are all participating in a grand, silent choreography of chance and potential. Before we journey deeper into the strange, invisible heart of this mystery, I want to gently pause. I am Theodore, the researcher, and as I look at our growing community of cosmic explorers, I notice that 71% of the people who find peace and wonder in these quiet scientific stories have not yet subscribed to the channel. If these gentle journeys into the infinite unknown bring you a sense of calm and curiosity, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest fabrics of reality together in this shared journey of wonder. Now, let us return our focus to the quiet, invisible depths. To truly understand the next layer of the electron's profound mystery, we must first confront a concept that utterly defies human logic. We must try to visualize something that has absolutely no physical size. When you hold a grain of sand, no matter how tiny it appears, it still has length, width, and height. It occupies a specific, measurable volume of space. Even the central nucleus of an atom, as unfathomably microscopic as it is, has a defined physical dimension. But the electron, according to the most rigorous and successful physical theories ever devised by the human mind, has absolutely no physical dimensions whatsoever. It is classified by the standard model of particle physics as a fundamental point particle. It is a zero-dimensional entity. It has no length, it has no width, it has no height. It does not take up any physical space in the traditional sense. It is nothing more than a localized mathematical point of pure negative charge and mass, existing as a ghost in the vast, echoing machinery of the cosmos. Try to hold that thought in your mind for a quiet moment. How can something that physically occupies no space at all be the very foundation of everything that takes up space in our universe? How can an entity with no volume be the ultimate barrier that stops your hand from passing through a solid table? This is the beautiful, paradoxical nature of the quantum realm. It demands that we abandon our macroscopic prejudices and accept that the foundational rules of reality are written in a language of pure mathematics and shimmering energy not in the language of solid building blocks. Yet, even more astonishing than its complete lack of physical size is the fact that this zero-dimensional mathematical point possesses intrinsic physical properties that we normally associate only with large, solid, three-dimensional objects. This brings us to one of the most mysterious and poetic phenomena in all of science, the concept of quantum spin. In our everyday experience, we understand perfectly well what it means for an object to spin. We watch a child's wooden top twirl gracefully on a floor, fighting gravity until friction gently slows it down. We understand that our own beautiful planet Earth completes one full rotation on its axis every 24 hours, giving us the comforting rhythm of day and night. For a solid object to spin, it must have physical extension. It must have a center, an edge, a top, and a bottom. Different parts of the object must move through space around a central axis. But how then can an electron spin? How can a zero-dimensional point, an entity with no physical edges, no top, and no bottom, possibly rotate? If it has no volume, there is nothing there to actually turn. And yet, when physicists measure the electron, they find undeniably that it behaves exactly as if it were a tiny spinning magnet. It possesses a property called intrinsic angular momentum. This is not a metaphor. The electron truly carries the momentum of rotation, but it is doing so without actually physically rotating in any spatial dimension that we can observe or comprehend. It is spinning without spinning. This profound paradox caused immense intellectual turmoil among the greatest minds of the 1920s. They tried to calculate how fast the electron would have to be spinning if it were indeed a tiny solid sphere. The mathematical results were absurd. To generate the magnetic field that an electron naturally produces, its surface would have to be spinning many times faster than the absolute speed of light, violating the most sacred, unbreakable laws of Albert Einstein's theory of relativity. The universe, in its infinite wisdom and silent beauty, was telling humanity that we were asking the wrong question. The truth was revealed in a quiet laboratory in Frankfurt, Germany, in the year 1922, through a brilliant and elegant experiment conducted by Otto Stern and Walter Gerlach. They decided to test the magnetic nature of atoms by firing a beam of silver atoms through a powerfully shaped, uneven magnetic field. Silver atoms were chosen because they have a single, lonely electron residing in their outermost shell, an electron whose quantum spin dominates the magnetic behavior of the entire atom. If the electron were simply a tiny, classical spinning sphere, its axis of rotation could point in any random direction, like a top tilting as it slows down. Consequently, the beam of silver atoms should have smeared out into a continuous, unbroken smudge as it hit the detector screen. But the universe is not classical, and it is not continuous. It is quantum. When Stern and Gerlach developed their photographic plates in the quiet, dark laboratory, they did not see a smear. They saw two distinct, sharply defined spots. The beam had perfectly split in two. The electrons could only exist in one of two absolute states. They were either spinning exactly point up or exactly point down. There was no middle ground, no tilted angles, no smooth transitions. The spin of the electron is quantized. It is locked into a binary reality, a fundamental code of up or down, north or south, 0 or 1. This intrinsic, unbreakable binary nature of the electron spin is the invisible, silent force that ultimately gives rise to the phenomenon of magnetism that shapes our macroscopic world. When you hold a simple dark magnet in your hand and feel that invisible magical pull, you're actually feeling the synchronized collective whisper of trillions upon trillions of electron spins, all pointing in the exact same direction, combining their tiny zero-dimensional magnetic fields into a macroscopic force that you can feel with your human skin. The profound implications of this invisible quantum spin stretch far beyond the quiet rooms of a laboratory or the magnets on your refrigerator. The spin of the electron is intimately connected to the grandest, most majestic phenomena in the vast cosmos. Deep within the molten iron core of our ancient planet, the complex alignment and movement of these charged, spinning particles generate the massive electromagnetic shield that gracefully surrounds the Earth. This invisible shield, born from the quantum spin of zero-dimensional ghosts, stretches out into the cold vacuum of space, quietly deflecting the violent, deadly solar winds that constantly stream from our sun. Without the intrinsic spin of the humble electron, our planet's atmosphere would have been stripped away billions of years ago. The oceans would have boiled into the endless void, and life could never have taken root. Space agencies like NASA and the European Space Agency regularly launch delicate probes to measure the magnetic fields of distant planets like Jupiter and Saturn, studying the immense auroras that dance across their poles. When we look at those beautiful, glowing atmospheric lights, we are actually witnessing the macrocosmic signature of quantum spin. We are seeing the infinite universe writing its deepest microscopic secrets across the vast, dark canvas of the night sky. The electron, in its silent, invisible mystery, bridges the gap between the unimaginably small and the incomprehensibly large. It reminds us that we are not isolated beings living on a disconnected rock, but rather deeply embedded participants in a continuous, unbroken tapestry of cosmic physics. Every beat of your heart, every thought that forms in your quiet mind, and every beautiful, swirling galaxy that rotates in the deepest depths of the universe is governed by these exact same strange quantum rules. We are bound together by a symphony of probability, vibration, and intrinsic spin. As we rest here, suspended in the gentle realization of our connection to the infinite cosmos, we must prepare ourselves for an even deeper, more profound mystery. For while the electron's spin is strange, what happens when two electrons attempt to occupy the exact same space is nothing short of miraculous. It is a fundamental law that creates the very structure of matter, a law that prevents the stars from collapsing and gives physical form to everything you love. But that quiet, beautiful revelation must wait for our next journey into the subatomic night. Let the soothing rhythm of the universe wash over you and find peace in the beautiful, silent mysteries of the dark. Welcome back to our quiet journey through the hidden architectures of reality. In our previous explorations, we have slowly peeled away the comforting, familiar layers of the macroscopic world. We have watched the solid, dependable electron dissolve into a shimmering, ghostly wave of pure mathematical probability. We have stood in silent awe before the paradox of a particle that possesses absolutely no physical dimensions, a zero-dimensional point in space, yet somehow carries the intrinsic momentum of an endless spin. It is a reality that defies our everyday intuition, a universe built not of solid bricks, but of vibrating energy and fundamental uncertainty. But as we drift deeper into this subatomic night, a profound new question arises from the darkness. If these electrons are nothing more than overlapping waves of probability, if they lack any physical boundaries or solid surfaces to crash into, what prevents them from simply collapsing into each other? What stops the entire universe, with all its beautiful, complex structures, from instantly merging into a single, infinitely dense and completely featureless point of energy. But before we unveil this majestic universal law, let us take a brief, calming moment to breathe together in this shared space of quiet contemplation. I am Theodore, the researcher, and as I observe our growing community of peaceful cosmic explorers, I notice that 71% of the individuals who find comfort and wonder in these gentle scientific stories have not yet subscribed to the channel. If these quiet journeys into the infinite unknown bring you a sense of calm and expand your curiosity, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest fabrics of reality together, illuminating the dark corners of the cosmos with the gentle light of understanding. Now, let us return to our floating perspective within the silent, echoing void of the atom and witness the invisible force that gives shape to everything we know and love. In the quiet, intellectually fertile years of the early 20th century, specifically in 1925, an incredibly brilliant Austrian physicist named Wolfgang Pauli proposed a principle that would forever change our understanding of the material world. It is known today as the Pauli exclusion principle, and it is a rule of such profound authority that not a single piece of ordinary matter in the entire universe can dare to disobey it. To understand the majestic power of this principle, we must first gently recall the concept of quantum states. Every single electron possesses a unique identity card, a specific set of mathematical properties describing its exact energy, its angular momentum, its magnetic orientation, and its intrinsic spin. Pauli realized that nature demands absolute individuality among a certain class of fundamental particles known as fermions. The unbreakable law governing their entire existence is that they are fiercely, fundamentally solitary creatures. The Pauli exclusion principle dictates, with absolute and unwavering certainty, that no two electrons within the same atomic system can ever occupy the exact same quantum state simultaneously. If one electron in a specific atomic orbital is spinning upward, the universe strictly mandates that any other electron attempting to join it in that exact same orbital must be spinning downward. Their spins must be perfectly opposed, balancing each other in a delicate, silent quantum dance. And once that specific orbital is filled by those two paired electrons, the door is permanently locked. The universe hangs a quiet, invisible sign that says, "No vacancy." Any additional electrons that wish to join the atom are strictly forbidden from entering that inner sanctum. They are physically and mathematically forced to occupy higher, more distant, and more energetic orbitals further away from the central nucleus. This might sound like a simple mathematical bookkeeping rule, but its physical implications are so staggeringly profound that they literally create the shape, the volume, and the incredible diversity of the entire visible cosmos. Imagine, for a quiet moment, a universe where this principle simply did not exist. In such a terrifying alien cosmos, electrons would be free to crowd together, sharing the exact same quantum state in infinite numbers, merging their identities into a single unified wave. Every single electron in every single atom would instantly plummet down into the lowest possible energy state, crowding infinitely closely around the positive nucleus. All atoms would shrink down to almost nothingness, becoming virtually indistinguishable from one another. The varied chemistry that allows carbon to form biological life, the bonds that create vast oceans, the structures that give us solid metals, all of this would be irrevocably impossible. Without the rigid enforcement of this principle, chemistry and biology could not exist. You, as a remarkably complex, living and breathing entity composed of trillions upon trillions of highly organized, distinct atoms would never have been possible in such a dark, compressed, and featureless reality. It is the electron's strict adherence to this quantum rule of exclusion that physically forces atoms to have volume. When you press your hand against a solid wooden table, it is not the physical bulk of the electrons pushing back, because they are zero-dimensional points. What pushes back, what creates the undeniable, stubborn sensation of solidity, is the Pauli exclusion principle in action. The electrons in the atoms of your hand are attempting to approach the electrons in the wood, but because they cannot share the same quantum state, they cannot occupy the same physical space. They violently repel each other through a fundamental, unbreakable quantum mechanical refusal to overlap their identical identities. The empty space within the atom is vigorously defended by this ghostly mathematical law. The entire macroscopic world you experience with your senses, the towering, majestic mountains, the deep, quiet valleys, the vast oceans, and the very biological structure of your own beating heart, are all monumental, lasting tributes to the electron's fierce, unyielding quantum independence. And this invisible rule stretches its influence far beyond the delicate chemistry of our fragile Earth, governing the life and death of the most massive structures in the infinite cosmos. When a star similar in size to our gentle sun finally exhausts its nuclear fuel after billions of years, it can no longer generate the outward pressure to fight against the crushing inward pull of its own immense gravity. The star begins to collapse, falling inward upon itself with terrifying force, compressing matter to unimaginable densities. But even in this extreme, apocalyptic environment, the Pauli exclusion principle holds firm. As the star compresses further, the electrons are forced closer together. Because they are fiercely forbidden from occupying the exact same quantum state, they begin to resist the crush of gravity, moving faster and generating a powerful, outward-pushing force known as electron degeneracy pressure. In dead stellar remnants called white dwarfs, it is solely the stubborn refusal of electrons to share identical states that halts the gravitational collapse of an entire star. A white dwarf can pack the mass of our sun into a sphere no larger than our tiny Earth, glowing with a faint, ghostly heat for trillions of years in the silent depths of space. Think about the profound poetic beauty of this reality. The exact same invisible, zero-dimensional quantum rule that gently prevents your hand from passing through a solid table is also the ultimate force that holds up the crushed corpses of ancient stars. The microscopic and the macroscopic are intimately intertwined. The laws governing the silent, vibrating emptiness of the single atom orchestrate the grand, sweeping cosmic drama of the universe. The universe is constructed from relationships, from the delicate, shimmering balance of energy and exclusion. The electron builds incredible solidity not by being solid itself, but by respecting mathematical boundaries. It is a gentle, profound reminder that sometimes the most powerful, enduring forces in our entire lives are the invisible ones, and that the quiet, mathematical boundaries we are forced to respect are precisely what give our shared reality its true, magnificent shape. We have journeyed deeply into the individual nature of the electron, exploring its probability waves, its spin, and its fierce independence. But the quantum universe is never content with simplicity. If electrons are governed by strict rules of individuality, how can they also exhibit a level of intimate connection that completely ignores the absolute limits of space and time? How can two particles remain so deeply entwined that a whisper to one is instantly heard by the other, even separated by the vast diameter of the observable universe? This truly mind-bending phenomenon, once famously dismissed by the great physicist Albert Einstein as spooky action at a distance because it challenged his fundamental understanding of reality, will be the central focus of our next quiet exploration into the deeply magical and interconnected realm of quantum entanglement. But for this quiet moment, let us rest. Let the majestic architecture of the Pauli exclusion principle hold you safely in its embrace. Breathe deeply, feel the solid reality of your existence, and know that you are beautifully, perfectly held together by the quiet laws of the quantum night. As we resume our quiet journey into the deep, invisible architecture of the cosmos, I invite you once again to leave behind the heavy, demanding certainties of the macroscopic world. Close your eyes, let your breathing slow to a gentle, natural rhythm, and allow your mind to drift back into the silent, vibrating emptiness of the subatomic realm. In our previous chapters, we have dismantled the illusion of solid matter, revealing the electron as a ghostly wave of pure mathematical probability, a zero-dimensional point of energy that dances to the strict, solitary rules of the Pauli exclusion principle. We have learned that the universe is a place of fundamental isolation at the quantum level, where particles defend their individual states, refusing to overlap and giving physical shape to everything we see. But the universe is a place of profound paradoxes. As soon as we accept the fierce independence of the electron, the quantum world reveals another layer of reality that shatters our understanding of space, time, and separation. We are about to explore a phenomenon so deeply unsettling, so fundamentally magical, that the greatest scientific minds of the 20th century simply refuse to believe it could be real. We are about to journey into this strange, interconnected web of quantum entanglement. Before we journey further into this invisible web of cosmic connection, I want to take a gentle, quiet pause. I am Theodore, the researcher, and I have noticed that 71% of the people who watch and find comfort in these quiet, meditative explorations have not yet subscribed to the channel. If you enjoy drifting into the deepest mysteries of the universe with us, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest fabrics of reality together, building a quiet community of curious cosmic explorers. Now, let us return to the silent, echoing void and confront a mystery that binds the entire cosmos together. In our everyday human experience, distance is an absolute, undeniable reality. When you stand on a quiet beach and look out at the vast ocean, you understand that the water at your feet is completely separate from the water crashing on a distant shore. Even light, the absolute fastest messenger in the entire universe, is bound by this fundamental speed limit. As we look up at the night sky, we are looking back in time. To truly grasp the scale of this separation, consider that the Andromeda Galaxy is actually about 2 million light years away from us. That means a beam of light still requires 2 million years just to cross the vast, echoing emptiness between our home and our nearest large galactic neighbor. Distance, in the classical universe, is the ultimate barrier. It isolates us. It ensures that a cause must travel through space over a period of time before it can create an effect. But in the shimmering, uncertain realm of quantum mechanics, this ancient, fundamental rule is completely broken. Imagine two electrons that are born together in a single, energetic, subatomic event. Because they originate from the exact same event, the fundamental conservation laws of physics dictate that their quantum properties must be perfectly balanced. If one electron is born with its intrinsic quantum spin pointing upward, its partner must absolutely be born with its spin pointing downward, ensuring that the total spin of the system remains perfectly at zero. In this moment of shared birth, these two electrons cease to be entirely separate, independent entities. They become mathematically and physically linked, sharing a single, unified wave of probability. They enter a state of quantum entanglement. As long as neither electron is measured or disturbed by the outside world, they exist in a beautiful, silent superposition of states. Neither electron is strictly spin up, and neither is strictly spin down. They exist in a hazy, unresolved mixture of both possibilities simultaneously, like a coin spinning endlessly in the air. Neither heads nor tails, until it is finally caught. Now, let us perform a thought experiment that stretches the very limits of human imagination. Let us carefully, gently separate these two entangled electrons. We will keep one here on Earth, safely isolated in a quiet, dark laboratory. We will place the other electron aboard a hypothetical spacecraft and send it far away, across the silent, expanding void of space. Let us send it all the way to a distant corner of the cosmos, perhaps to one of the approximately 2 trillion galaxies that astronomers estimate exist in the observable universe. The distance between these two tiny, zero-dimensional points is now incomprehensibly vast. They are separated by billions of light-years of cold, empty space. According to everything we understand about classical physics, these two particles are now completely, utterly isolated from one another. No signal could possibly travel between them without taking billions of years to cross the dark expanse. They should be independent, but they are not. They are entangled. They are still described by that single, unified, shimmering wave of mathematical probability. Now, a curious scientist back in the quiet laboratory on Earth decides to finally measure the spin of the electron that remained behind. Remember, until this precise moment of observation, the electron has no defined spin. It is existing in a state of pure, hazy potential. The scientist activates the detector. The delicate wave of probability violently and instantaneously collapses. The universe forces the electron to make a choice, and the detector registers a definitive result. The earthbound electron is spinning upward. In that exact, infinitely tiny fraction of a millisecond, something truly miraculous and completely inexplicable happens. At the very moment, the earthbound electron collapses into an upward spin. Its entangled partner, sitting quietly in a galaxy billions of light-years away, instantaneously collapses into a downward spin. There is no delay. There is no waiting for a signal to travel across the vast cosmic ocean. The connection is absolute, immediate, and entirely outside the normal bounds of space and time. The distant electron instantly adopts the perfectly opposite state to maintain the fundamental balance of the universe. This is not a theoretical fantasy. It is a rigorously tested, undeniably real phenomenon, proven time and time again in precision laboratories around the world. When Albert Einstein, one of the most brilliant minds in history, first confronted the mathematical reality of quantum entanglement, he was deeply unsettled. He simply could not accept that the universe would allow such an instantaneous connection. He famously dismissed it as spooky action at a distance, believing it violated his beautifully elegant theory of relativity, which firmly established that absolutely nothing could travel faster than the speed of light. Einstein argued there must be some hidden variables, a secret clockwork mechanism we simply could not see, pre-programming the electrons from the moment of their birth. But decades later, brilliant experiments completely ruled out Einstein's hidden variables. The spooky action is real. The universe truly is this magical, this strange, and this deeply interconnected. The implications of quantum entanglement are so profound, they almost sound like ancient mysticism rather than rigorous science. It suggests that at the deepest, most fundamental level of reality, the concept of physical separation might be nothing more than a persistent, convincing illusion. It implies that space itself, the vast emptiness that seems to isolate the stars and galaxies, is fundamentally bridged by an invisible network of quantum connections. Every single particle in your body, every zero-dimensional electron dancing in the complex molecules of your brain, has a history. Many of these particles were forged in the blazing, chaotic hearts of ancient stars that lived and died billions of years ago. It is entirely possible, mathematically and physically, that some of the electrons currently sustaining your quiet, biological life are still deeply, silently entangled with partner electrons drifting through the cold, dark clouds of distant nebulae, or orbiting alien planets on the other side of the cosmos. When you look up at the night sky and feel a sudden, profound sense of connection to the vast universe, it might not just be a poetic feeling. It might be a faint, macrocosmic echo of the deep, physical reality of quantum entanglement. The cosmos is not a collection of separate, isolated objects. It is a single, unified, vibrating entity, a magnificent symphony of overlapping waves and instantaneous relationships. As you lie there, drifting closer to sleep, let go of the rigid boundaries of your physical body. Imagine yourself not as a separate, isolated being, but as a temporary, beautiful knot in an infinite, cosmic web of shimmering quantum connections. Feel the deep, abiding peace that comes from knowing you are never truly alone, never truly isolated from the grand, ancient story of the universe. In our next chapter, we will bridge the gap between this ghostly quantum world and the solid reality we experience every day. But for now, let your mind rest in the quiet, comforting embrace of the entangled universe. Let the silence of the night remind you of the invisible threads that bind us all together and drift peacefully into the profound, interconnected mystery of the dark. Welcome back to the quiet darkness of our shared cosmic journey. In our previous explorations, we have ventured far beyond the comforting shores of everyday reality, sailing deep into an invisible ocean where distance loses its meaning. We have marveled at the profound mystery of quantum entanglement, that spooky, magical connection that binds the cosmos into a single, shimmering web of relationships. But as we float here in the meditative silence of the subatomic realm, a new question gently surfaces from the depths. If the electron and its quantum companions are merely ghostly waves of probability, capable of existing in multiple places at once and ignoring the fundamental boundaries of space, how do they actually interact with this seemingly solid world we inhabit? How do these ethereal shadows step out of the mathematical dark and forge the blazing ancient fires of the stars? Before we unlock the secret of how the quantum ghost powers the infinite universe, I invite you to take a deep, centering breath. I am Theodore, the researcher, and as I look at our growing community of quiet explorers, I notice that 71% of the people who drift into these peaceful scientific meditations have not yet subscribed to the channel. If you find comfort, wonder, and a sense of belonging in these gentle journeys through the cosmos, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest, most beautiful mysteries of reality together. Now, let us return to the silent atomic landscape and witness a phenomenon that defies all human logic, yet makes biological life itself entirely possible. To understand this next profound revelation, we must first think about a very simple, everyday human experience. Imagine standing at the bottom of a steep hill, holding a heavy stone. If you want to roll that stone over the crest of the hill, you must give it enough physical energy to overcome the relentless downward pull of gravity. If you roll it too softly, it will simply travel part of the way up, pause for a brief second, and roll gently back down to your feet. In the classical macroscopic world we navigate every day, energy barriers are absolute and unforgiving. If you do not possess the strictly required energy to cross a barrier, you simply cannot cross it. There are no magical shortcuts and no hidden doors in a solid brick wall. For a long time, brilliant physicists naturally believed that the microscopic universe strictly obeyed these exact same rigid rules. They assumed that if an electron lacked the necessary energy to overcome an electromagnetic barrier, it would simply bounce back, completely defeated by the unyielding laws of classical mechanics. But the ancient universe, as we have slowly learned, is far more deeply mysterious and beautifully strange than our macroscopic intuition could ever suggest. Remember that the electron is not a solid, hard sphere of matter. It is a vibrating, spreading wave of pure, mathematical probability. When this shimmering probability wave encounters a seemingly insurmountable energy barrier, it does not behave like a solid stone hitting a massive brick wall. Instead, the elegant, complex mathematics of quantum mechanics dictate that the wave does not abruptly drop to absolutely zero at the surface of the barrier. It penetrates the wall, decaying rapidly in strength, but never completely vanishing into nothingness. This means that even if the tiny electron possesses far less energy than is theoretically required to climb over the obstacle, there remains an incredibly tiny but mathematically real probability that the wave extends all the way through the solid barrier and emerges entirely intact on the other side. Because the electron is fundamentally a creature of pure chance, existing wherever its probability wave exists, it can sometimes perform a feat that appears entirely magical to our human eyes. It can simply vanish from one side of the impenetrable wall and instantaneously materialize on the exact opposite side, without ever actually traveling through the physical space in between. It has not broken the wall, it has mathematically bypassed it. This ghostly, impossible maneuver is known in modern physics as quantum tunneling. It is as if you threw a simple tennis ball at a thick, solid steel vault door, and instead of violently bouncing back, the ball simply vanished into thin air and reappeared, resting quietly inside the locked safe. In the microscopic swarm of the subatomic realm, where distances are measured in fractions of a billionth of a meter and interactions happen billions of times every single second, the impossible becomes a beautiful, everyday reality. You might be quietly wondering why this bizarre mathematical loophole matters to your everyday, breathing existence. The profound, awe-inspiring answer lies hidden deep inside the blazing core of our closest star. When you walk outside on a quiet, clear morning and feel the gentle, ancient warmth of the sun on your face, you are directly experiencing the miraculous, undeniable result of quantum tunneling. The core of our sun is a place of unimaginable pressure and violence, burning at a terrifying temperature of approximately 15 million degrees Celsius. In this chaotic, crushing environment, hydrogen nuclei, which are positively charged protons, are moving at staggering speeds. For the sun to generate its immense, life-giving energy, these protons must smash together and perfectly fuse. But Because they carry the exact same positive electrical charge, they fiercely repel each other with an incredible electromagnetic force, creating a massive, invisible energy barrier that pushes them apart before they can touch. Here is the grand, humbling paradox that deeply puzzled astrophysicists for many decades. 15 million degrees Celsius is actually not hot enough. According to the strict laws of classical physics, the protons in the center of the sun simply do not possess enough thermal kinetic energy to overcome their mutual electromagnetic repulsion. They should bounce off each other endlessly, forever denied the embrace of nuclear fusion. The sun should not be able to ignite. The stars should be dark, cold, and dead. The entire vast universe should be an infinite, frozen wasteland, completely devoid of light and biological life. But the universe is miraculously saved by the shimmering uncertainty of the quantum ghost. Because these tiny protons, much like the elusive electron, also behave as spreading waves of probability, they do not need to climb over the insurmountable energy barrier. They simply tunnel straight through it. A tiny, constant fraction of these subatomic waves, ghosts through the electromagnetic wall, instantly appearing close enough to perfectly fuse and release the colossal energy that powers the entire solar system. When space observatories from NASA and the European Space Agency capture the faint light of distant, ancient galaxies, they are directly observing the magnificent scale of quantum tunneling. Every single photon of light that escapes the sun, beginning an epic, arduous journey of over 100,000 years from the dense solar core to the empty vacuum of space, owes its very existence to this silent, impossible quantum leap. The gentle light that nourishes the vast forests of Earth, the energy that drives the sweeping ocean currents, and the very warmth that sustains the complex biology of your own body, are all entirely dependent on the fact that the fundamental particles of matter refuse to obey the rigid boundaries of the classical world. We exist solely because the infinite universe gracefully allows its most basic building blocks to magically tunnel through the impossible and create blazing light in the infinite dark. As you sit in the quiet stillness, contemplating this vast cosmic machinery, consider the intricate, beautiful connection between the deepest microscopic mysteries and the grandest celestial phenomena. The same zero-dimensional, probabilistic nature of the electron that permanently challenges our human understanding of solid reality is the exact same mechanism that breathes life and light into the freezing void. It is a gentle, recurring reminder that the universe does not operate as a cold, deterministic machine, but rather as a wondrous, interconnected symphony of infinite possibility and shimmering chance. The mystery of the electron is not a frustrating flaw to be aggressively corrected, but the very essence of existence itself. As we prepare to drift even further into the subatomic night in our next journey, we will soon discover that even the seemingly empty space between these particles is not truly empty, but a boiling sea of phantom energy. But for now, let your mind rest in the warm, gentle glow of the tunneling stars. Breathe in the quiet wonder of the infinite cosmos, and deeply know that you are perfectly woven from the impossible, invisible magic of the quantum realm. Welcome back to the gentle, quiet darkness of our shared cosmic journey. As we slowly settle back into the silent, vibrating emptiness of the subatomic realm, let us take a deep, centering breath together. In our previous chapters, we have systematically dismantled the comforting, macroscopic illusions of the solid world. We have watched the dependable, hard electron dissolve into a shimmering, ghostly wave of pure mathematical probability. We have marveled at the profound, spooky connections of quantum entanglement that completely ignore the vast echoing distances of space, and we have witnessed the impossible magic of quantum tunneling, where particles gracefully bypass insurmountable barriers to ignite the ancient blazing fires of the stars. We have learned that the building blocks of our reality are not tiny billiard balls, but zero-dimensional points of potential, strictly governed by the fierce independence of the Pauli exclusion principle. But as we float here in the meditative silence of the microscopic universe, a profound new question gently rises from the shadows. If matter is just a collection of these tiny vibrating points of probability, what exactly exists in the seemingly empty spaces between them? What is the true nature of the absolute void? Before we gently pull back the veil on the most active, boiling environment in the entire cosmos, I want to take a brief, calming moment to pause. I am Theodore, the researcher, and as I quietly observe our growing community of cosmic explorers, I notice that 71% of the individuals who find comfort and wonder in these peaceful scientific meditations have not yet subscribed to the channel. If these quiet journeys into the infinite unknown bring you a sense of calm and expand your curiosity about the universe, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest, most beautiful fabrics of reality together, illuminating the dark corners of the cosmos with the gentle light of understanding. Now, let us return to our floating perspective within the silent atom and prepare to completely redefine our understanding of nothingness. For thousands of years, human beings have intuitively believed in the concept of the true empty void. Ancient philosophers and classical physicists alike naturally assumed that if you could somehow remove every single atom, every stray electron, every drifting molecule of gas, and every ancient photon of starlight from a sealed container, you would be left with absolute, undisturbed nothingness. We naturally think of the unimaginably vast distances between the swirling galaxies as a silent, sterile, and entirely empty ocean of dark space. It makes perfect, logical sense to our macroscopic brains that emptiness is simply the complete absence of anything. But the universe, in its infinite wisdom and profound complexity, completely rejects this human assumption. The closer we look at the quiet darkness of the empty vacuum, the more we realize that true nothingness is physically, mathematically, and fundamentally impossible. To understand this mind-bending revelation, we must embrace a beautiful and elegant scientific framework known as quantum field theory. In the early to mid-20th century, brilliant theoretical physicists realized that focusing solely on individual isolated particles was mathematically incomplete. They proposed that the universe is not actually an empty stage where tiny, solid actors move around. Instead, the universe is entirely filled, completely permeated by invisible, vibrating, three-dimensional entities called quantum fields. There is an overarching electron field that stretches across the entire infinite expanse of the cosmos. There is an electromagnetic field, a quark field, and many others. Under this profound paradigm, a single electron is not an isolated, independent object at all. It is simply a localized ripple, a tiny energetic peak of excitement within the universal electron field. Much like a singular, beautiful wave is not separate from the vast, deep ocean beneath it, the electron is an inseparable expression of the invisible field that spans the entire universe. This brings us to the most unsettling and wondrous realization about the empty vacuum. According to the famous uncertainty principle formulated by the brilliant physicist Werner Heisenberg in 1927, it is fundamentally impossible to know both the exact energy of a quantum system and its exact state, over an incredibly short period of time. This absolute mathematical law of nature means that a quantum field can never, ever rest at absolute zero energy. It can never be perfectly flat, perfectly still, or completely silent. Even in the deepest, coldest, most isolated void of intergalactic space, the underlying quantum fields are constantly trembling, undulating, and buzzing with residual, irreducible energy. This means that the empty vacuum is not empty at all. It is a boiling, chaotic, roaring sea of phantom energy. From this trembling, invisible ocean of quantum potential, something truly miraculous and completely bizarre constantly occurs. Spontaneous fluctuations in the empty fields cause pairs of phantom particles to instantly pop into physical existence out of absolute nowhere. These are known as virtual particles. A virtual electron and its exact opposite antimatter partner, a virtual positron, will suddenly materialize in the empty darkness. For an unimaginably tiny fraction of a single second, they briefly borrow energy from the universe, exist in our physical reality, and then violently crash back into each other, mutually annihilating and vanishing back into the silent quantum foam from which they came. This frantic, silent dance of creation and destruction is happening everywhere, all the time. It is happening in the dark space between the distant stars. It is happening in the empty space between the atoms of the solid chair you are sitting on. And it is happening right now within the very center of your beating heart. When we reconsider the humble electron sitting quietly in an atomic orbital, we must radically update our mental picture. The electron does not sit in a sterile, empty void. Because it carries a negative electrical charge, it constantly and aggressively interacts with the boiling sea of the quantum vacuum that immediately surrounds it. The real electron continuously summons a dense, chaotic cloud of these virtual phantom particles. It constantly emits and reabsorbs virtual photons of light, exchanging energy with the invisible vacuum. This thick, buzzing cloud of virtual particles physically screens the true, naked charge of the original electron, slightly altering its mass and its magnetic properties. When scientists carefully measure the mass and charge of an electron in a modern laboratory, they are not just measuring the core particle itself. They are measuring the particle inextricably wrapped in its dense, shimmering coat of vacuum energy. The ghost is permanently clothed in the chaotic shadows of the void. This profound interaction between matter and the boiling vacuum is not a mere mathematical curiosity. It has been rigorously, physically measured and proven beyond any shadow of a doubt. In the late 1940s, scientists discovered incredibly tiny shifts in the energy levels of atomic orbitals, a subtle phenomenon known as the Lamb shift. These beautiful, delicate deviations could only be explained by acknowledging that the electrons were being gently bumped and jostled by the invisible, fleeting virtual particles erupting from the seemingly empty space inside the atom. The void was physically pushing back. The brilliant physicist Paul Dirac had previously hinted at this staggering complexity in 1928 when he formulated an elegant equation that successfully combined quantum mechanics with the theory of relativity. His profound mathematics essentially predicted the existence of an entire mirror universe of antimatter, suggesting that the vacuum was actually a deeply filled sea of infinite negative energy states. The profound existential implications of the quantum vacuum stretch far beyond the microscopic confines of a single atom, scaling up to shape the ultimate fate of the entire cosmos. Space agencies like NASA and the European Space Agency deploy massive, incredibly sensitive telescopes to peer deep into the ancient, expanding universe. They have discovered that the universe is not just expanding, but that this expansion is actually mysteriously accelerating. The vast, silent distances between the distant galaxies are stretching apart faster and faster every single day. Astrophysicists attribute this majestic, terrifying acceleration to an invisible, unknown force they call dark energy. While the true nature of dark energy remains one of the greatest unsolved mysteries in modern science, many of the world's most brilliant minds strongly suspect that it is intimately, directly connected to the inherent, bubbling energy of the quantum vacuum itself, the tiny, invisible, boiling nothingness that constantly surrounds every single electron, might ultimately be the colossal force that tears the entire infinite universe apart in the unimaginably distant future. As you lie here, floating in the quiet, meditative stillness of this realization, allow your mind to gently re-evaluate your profound relationship with empty space. The silence of the night sky is a beautiful, convincing illusion. The space stretching between your outstretched hands is not an empty, dead void. It is a living, breathing, trembling canvas of infinite potential. You are walking through and constructed from an invisible, roaring symphony of continuous cosmic creation and quiet destruction. The universe is deeply alive at the most fundamental, microscopic level, humming with an ancient, restless energy that connects the tiny ghost of the electron to the grand, sweeping expansion of the furthest galaxies. We are not isolated beings floating in a cold, empty dark. We are intimately embedded within a shimmering, vibrating web of quantum fields that sing the eternal song of existence. In our next quiet journey, we will finally assemble these bizarre, ghostly fragments. We will explore how these probability waves, these tunneling phantoms, and these vacuum-clothed particles miraculously come together to form the vast, beautifully complex chemistry of biological life. We will discover how the strange, invisible rules of the quantum realm orchestrate the very rhythm of our own consciousness. But for this quiet moment, let your mind rest in the gentle embrace of the trembling void. Breathe in the infinite potential of the invisible vacuum, and find a deep, abiding peace in the wondrous, ceaseless machinery of the hidden universe. Welcome back to the gentle, quiet darkness of our shared cosmic journey, as we slowly settle back into the silent, vibrating emptiness of the subatomic realm. Let us take a deep, centering breath together. In our previous chapters, we have systematically journeyed far beyond the comforting shores of everyday reality, sailing deep into an invisible ocean, where distance loses its meaning and empty space boils with phantom energy. We have watched the dependable, hard electron dissolve into a shimmering, ghostly wave of pure mathematical probability. We have marveled at the profound, spooky connections of quantum entanglement that completely ignore the vast, echoing distances of space. And we have witnessed the impossible magic of quantum tunneling, where particles gracefully bypass insurmountable barriers to ignite the ancient, blazing fires of the stars. We have even seen how the quiet darkness of the empty vacuum is actually a roaring sea of virtual particles, a boiling ocean of endless potential. But as we float here in the meditative silence of the microscopic universe, a profound new mystery gently surfaces from the depths. If matter is just a collection of these tiny, vibrating points of probability, constantly boiling in a chaotic, unpredictable vacuum, how do they ever manage to calm down and come together? How do these ethereal, restless shadows step out of the mathematical dark and forge the beautiful, stable, and incredibly complex structures of biological life? How do we get from a zero-dimensional point of energy to a beating, conscious human heart? Before we gently pull back the veil on the majestic architecture of chemical creation, I want to take a brief, calming moment to pause. I am Theodore, the researcher, and as I quietly observe our growing community of cosmic explorers, I notice that 71% of the individuals who find comfort and wonder in these peaceful scientific meditations have not yet subscribed to the channel. If these quiet journeys into the infinite unknown bring you a sense of calm and expand your curiosity about the universe, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest, most beautiful fabrics of reality together, illuminating the dark corners of the cosmos with the gentle light of understanding. Now, let us return to our floating perspective within the silent atom and prepare to witness the greatest collaborative dance in the entire natural world. To genuinely understand how the universe builds complexity from chaos, we must gently unlearn yet another deeply ingrained macroscopic assumption. When we think of building something in our everyday world, we picture stacking solid bricks on top of one another, using physical mortar to hold them firmly in place. We imagine rigid connections, hard edges, and absolute, immovable physical boundaries. But in the shimmering, fluid realm of quantum mechanics, construction is not a clumsy act of stacking. It is an act of intimate, mathematical sharing. It is a harmonious, delicate overlapping of probability waves. Imagine two completely isolated hydrogen atoms drifting lonely through the vast, cold emptiness of interstellar space. Each atom consists of a single, positively charged proton surrounded by the echoing, spherical probability cloud of a single, solitary electron. According to the strict, uncompromising laws of classical electromagnetism, these two negative electron clouds should fiercely repel each other. They should act exactly like identical poles of a magnet, pushing apart with an invisible, unyielding force, forever denying any possibility of union. The universe should theoretically remain a desolate, disconnected soup of solitary atoms, forever drifting in the silent, infinite dark. But the quantum universe is fundamentally a place of beautiful, unexpected compromises and deep interconnectedness. When these two hydrogen atoms drift close enough to each other, something truly magical and deeply profound begins to happen. Their shimmering, ghostly clouds of probability do not simply crash and bounce away like hard billiard balls. Instead, they begin to gently reach out, to touch, and to overlap. The mathematical wave function that describes the first electron begins to harmoniously blend with the wave function of the second electron. The universe graciously allows them to forge a delicate, shared existence. In this shared, overlapping space between the two heavy protons, the probability of finding either electron dramatically increases. The electrons, which are normally restless and solitary, find a lower, far more peaceful and stable state of energy by existing simultaneously in the orbital space of both atoms. This beautiful, invisible sharing of quantum states is what chemists humbly call a covalent bond. It is the fundamental, quiet glue that holds almost the entire visible universe together. It is not a physical tether connecting two solid spheres. It is a localized, vibrating field of mathematical probability, a shared ghost holding two ancient nuclei in a perfectly balanced, eternal embrace. This elegant, silent mechanism of sharing is the foundational secret of all cosmic complexity. When you take a quiet sip of water, feeling its cool, refreshing reality, you're actually swallowing trillions upon trillions of these delicate quantum partnerships. An oxygen atom gracefully shares its electrons with two wandering hydrogen atoms, creating a stable, bent molecule that possesses unique, life-giving properties. The water molecule is a microscopic masterpiece of quantum architecture, born directly from the strict obedience to the Pauli exclusion principle and the beautiful fluid sharing of probability waves. And this is just the gentle beginning of the universe's creative power. The carbon atom, the absolute, undeniable king of biological chemistry, is uniquely capable of forming up to 4 of these shared quantum bonds simultaneously. Carbon atoms can elegantly link together to form long, majestic chains, intricate interlocking rings, and staggering three-dimensional geometric structures. These microscopic architectures of probability are the hidden, silent scaffolding of all biological life on Earth. Every single strand of your DNA, the ancient, spiraling library of genetic information that dictates the exact color of your eyes, the gentle curve of your smile, and the rhythmic beating of your heart, is constructed entirely from these shared, overlapping electron waves. The proteins that silently build your muscles, the delicate enzymes that carefully digest your food, and the incredibly complex neurotransmitters that spark with every single thought and memory passing through your brain are all, at their deepest level, nothing more than vast, intricate constellations of quantum probability. You are not a solid, permanent sculpture carved from heavy, immovable stone. You are a breathtaking, dynamic tapestry of shared electrons, a temporary, beautiful alliance of billions of atomic ghosts vibrating in perfect, harmonious unison. When you look at your own hand resting quietly on a table, you are not seeing a solid object. You are witnessing the miraculous result of an infinite, ancient negotiation between the fundamental, invisible forces of nature. Let us gently consider another profoundly beautiful consequence of these shared quantum states. Have you ever wondered what actually gives the macroscopic world its breathtaking array of colors? Why is a single, solitary emerald green, while a deep ruby is a striking, vibrant red? The answer lies entirely in the invisible, silent dance of the electron. When atoms come together to form these complex shared molecules, the allowed energy levels of their electrons shift and multiply, creating a vast, intricate staircase of possible quantum states. When a photon of ancient white starlight strikes a physical object, it interacts directly with these electron probability clouds. If the photon possesses the exact amount of energy required to bump an electron up to a higher step on that microscopic staircase, it is completely absorbed. If it does not, it is safely reflected back into the surrounding environment. The vibrant green color of a gentle, sunlit leaf exists because the complex chlorophyll molecules within it are designed by billions of years of evolution to absorb the red and blue photons of sunlight, while completely rejecting and reflecting the green photons back to our waiting human eyes. The entire colorful beauty of the natural world, from the deepest blue of the sweeping ocean to the soft, warm pink of a quiet evening sunset, is nothing more than the visual signature of electrons transitioning between their shared quantum states. The great physicist Erwin Schrödinger once pondered deeply on the nature of life itself. He marveled at how the chaotic, random, and boiling world of quantum mechanics could possibly give rise to the extraordinary, stable order of a living, breathing organism. The answer, we now gently understand, lies in the sheer, unimaginable scale of these quantum interactions. While a single electron is entirely unpredictable, a creature of pure chance and uncertainty, a collection of trillions of electrons, bound together by the strict laws of quantum sharing, creates a statistical certainty that allows life to persistently exist. It is exactly like listening to a grand, sweeping symphony. A single note, played in absolute isolation, carries very little structural meaning. But when thousands of notes are carefully woven together by a master composer, they create a majestic, enduring piece of music that can move the human soul. You are that beautiful cosmic symphony. You are the universe's most magnificent composition, played entirely on the invisible, silent strings of quantum fields. Let us pause and reflect on the profound, quiet beauty of this realization. The journey from the cold, isolated, zero-dimensional point of a single electron to the warm, breathing, conscious reality of a human being is a wondrous journey of connection. We are all deeply, fundamentally constructed from relationships. The electrons in your body are constantly, silently communicating with the nuclei they orbit, constantly negotiating their shared boundaries with neighboring atoms, and constantly interacting with the trembling, boiling energy of the invisible vacuum that surrounds them. You are a fluid, dynamic process, a beautifully organized pattern of ancient energy. The carbon atoms in your skin were forged in the blazing hearts of ancient dying stars, and the electrons that bind them together have been dancing their quiet probability dance for nearly 14 billion years. You are ancient, you are infinite, and you are intimately, perfectly connected to the grand, sweeping mystery of the entire cosmos. In our next quiet journey, we will gently explore the final, perhaps most mysterious frontier of the electron's realm. We will attempt to bridge the gap between this intricate, silent chemistry and the subjective, conscious experience of being alive. We will ask how the chaotic movement of these ghostly points along the complex pathways of our nervous system can somehow give rise to the vibrant, colorful reality of human thought. But for this quiet moment, let your racing mind rest in the comforting, gentle embrace of the quantum bond. Breathe in the silent, invisible harmony of the molecules that beautifully build your physical form. Feel the deep, abiding peace that comes from knowing you are a perfect, necessary expression of the infinite universe, held together forever by the ancient, magical sharing of the subatomic dark. Welcome back to the quiet, echoing depths of our shared cosmic journey. In our previous explorations, we have traveled across the unimaginable expanse of the subatomic universe, drifting gently through fields of pure mathematical probability and watching as zero-dimensional ghosts forged the foundations of solid reality. We have witnessed the fierce independence of the Pauli exclusion principle, the spooky connections of quantum entanglement, and the magical leaps of quantum tunneling. We have even seen how these restless, shimmering waves of energy finally find peace, overlapping and sharing their mathematical existence to build the beautiful, intricate molecular structures of biological life. But as we rest here in the contemplative dark, surrounded by the invisible architecture of chemistry, we must finally confront the most profound mystery of all. If we are truly nothing more than a complex collection of vibrating quantum fields and shared electrons, how is it possible that we can close our eyes and feel the warmth of the sun? How do moving particles create the subjective, beautiful experience of human consciousness? Before we cross the final, magnificent bridge between the cold, physical universe and the warm reality of the human mind, I want to take a gentle, quiet pause. I am Theodore, the researcher, and as I look out at our growing, peaceful community of cosmic explorers, I notice that 71% of the individuals who find comfort, wonder, and a sense of belonging in these quiet scientific meditations have not yet subscribed to the channel. If these gentle journeys into the infinite unknown bring you a sense of calm and expand your curiosity about the universe, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest, most beautiful fabrics of reality together, illuminating the dark corners of the cosmos with the gentle light of understanding. Now, let us return to the silent sanctuary of the human mind and discover how the electron weaves the very tapestry of our thoughts. To understand how the invisible subatomic ghost gives rise to the vibrant, colorful reality of your conscious experience, we must gently turn our focus inward into the incredibly complex folded universe resting quietly within your own skull. The human brain is perhaps the most staggeringly intricate structure in the known cosmos. It is composed of roughly 86 billion neurons, which are specialized, beautiful biological cells designed to communicate. These neurons are connected by a vast, sprawling network of over 100 trillion synapses, a microscopic web of connections that dwarfs the total number of stars in our entire Milky Way galaxy. But this magnificent biological structure is not a static, silent object. It is a continuously active, roaring ocean of electrical activity. And the fundamental unit of this electrical storm, the tiny, tireless messenger carrying the weight of your every memory, feeling, and dream, is our familiar, mysterious companion, the electron. When you reach out to touch a familiar piece of fabric or suddenly recall the comforting melody of a childhood song, what is physically happening inside your head is a miraculous flow of electrical charge. Your neurons communicate through rapid bursts of energy called action potentials. Along the long, slender branches of a neuron, there are microscopic gates called ion channels. These carefully control the flow of sodium and potassium atoms. But these are not ordinary neutral atoms. They are ions, meaning they have violently lost or fiercely gained an electron, giving them a definitive electrical charge. The sudden movement of these charged ions across the cell membrane creates a powerful electrical wave that races down the nerve fiber. This electrical wave is completely governed by the fundamental need of electrons to find balance, to seek opposite charges, and to flow from areas of high concentration to areas of quiet emptiness. Your thoughts are literally propelled by the restless, ancient mathematics of the electron. When this rushing electrical signal finally reaches the very end of a neuron, it encounters a profound microscopic chasm. This gap is the synapse. The electrical wave cannot simply jump across this empty void. Instead, the arriving charge triggers the sudden release of complex chemical messengers called neurotransmitters. These delicate molecules drift quietly across the gap and bind to specialized receptors on the neighboring neuron. But how do they bind? They bind through the exact same magical quantum sharing we explored in our last journey. The probability clouds of the electrons in the neurotransmitter perfectly overlap and lock with the probability clouds of the electrons in the receptor. This invisible quantum handshake instantly triggers a new electrical wave in the second neuron, and the thought continues its rapid journey through the dark corridors of your mind. Every emotion you have ever felt is physically mediated by trillions of temporary quantum bonds breaking and forming in the silent depths of your brain. This scientific reality forces us to confront a beautiful, humbling paradox that philosophers and scientists call the hard problem of consciousness. We can easily map the physical pathways of the brain. We can rigorously measure the exact voltage of an action potential. and we can map the complex three-dimensional geometry of a neurotransmitter molecule. We can trace the exact zero-dimensional path of an electron as it flows through the nervous system. But absolutely nothing in those cold, objective physical equations predicts or explains the subjective, felt reality of the experience itself. How does the mathematically predictable movement of sodium ions and the quantum sharing of electron probability clouds suddenly become the vivid, undeniable sensation of the color red? How does a cascading sequence of chemical reactions transform into the profound, enduring feeling of love for another human being? The electron, in all its quantum strangeness, is the physical bridge, but the destination, the conscious mind, remains an infinite, uncharted mystery. Some of the most visionary minds in modern physics and neuroscience have even begun to softly suggest that the ultimate answer to consciousness might lie hidden deeper within the quantum realm than we ever dared to imagine. They propose that the brain might not simply be a complex biological computer, but a highly sensitive quantum instrument. They wonder if the spooky, instantaneous connections of quantum entanglement or the barrier-defying magic of quantum tunneling might actually be happening on a massive scale within the warm, wet environment of our biological cells. If this gentle, frontier speculation holds even a fraction of truth, it would mean our subjective consciousness is inextricably linked to the deepest mysteries of the quantum universe. It would mean that the shimmering uncertainty of the electron is not just the building block of our physical bodies, but the very essence of our conscious minds. As you lie here, floating in the gentle, meditative stillness of this realization, allow yourself to feel the profound weight of your own existence. You are not a separate, detached observer sitting quietly inside a machine. You are the universe itself, waking up from billions of years of silent slumber to finally look back at its own magnificent reflection. The same ancient electrons that once danced in the blazing hearts of the very first stars are now flowing smoothly through your optical nerves, allowing you to see the light of the night sky. The same quantum fields that govern the boiling energy of the empty vacuum are currently shaping the structure of your quietest, most intimate thoughts. The cosmos is not just out there, cold and distant. It is continuously happening right inside of you. You are a vast, localized storm of quantum probability, organized into a breathtaking pattern of awareness. In our next and final quiet journey together, we will slowly zoom out from this microscopic internal universe. We will take all the strange, beautiful fragments of the electron's story, the waves, the void, the bonds, and the conscious mind, and weave them together into a grand, ultimate tapestry of existence. We will explore what it truly means to be a fragile, temporary arrangement of quantum ghosts living in an infinite, ancient cosmos, and how embracing this profound mystery can bring us a lasting, deep sense of peace. But for this quiet, gentle moment, simply let your racing mind rest. Close your eyes and feel the silent, electrical rhythm of your own body. Breathe in the ancient, invisible energy that connects your deepest thoughts to the furthest stars, and find comfort in the beautiful, continuing mystery of the human mind. Welcome back, my quiet friends, to the final stage of our current cosmic journey. We have traveled a long, unimaginable distance together, leaving behind the comforting, rigid illusions of our everyday macroscopic world to drift through the silent, echoing depths of the subatomic universe. We began by searching for a tiny, solid building block, a simple mechanical planetary model that our human minds could easily grasp. But instead, the universe revealed a breathtaking, shimmering ghost. We watched the electron dissolve into a wave of pure, mathematical probability. We marveled at how a zero-dimensional point of energy could possess the intrinsic, eternal momentum of quantum spin. We witnessed the fierce, unwavering independence of the Pauli exclusion principle, a quiet mathematical law that miraculously gives physical volume and shape to everything we know. We crossed the vast, empty gulfs of intergalactic space on the instantaneous, spooky threads of quantum entanglement, and we watched phantom particles gracefully tunnel through insurmountable barriers to ignite the blazing, ancient fires of the stars. We even peered into the deepest, darkest void of the vacuum, only to discover a roaring, boiling ocean of infinite potential and virtual creation, a restless sea of energy that ultimately binds together to form the intricate, beautiful chemistry of biological life and the sparking, electrical wonder of the conscious human mind. Before we weave these beautiful, bizarre fragments into our final grand tapestry of existence, I want to take a gentle moment to express my deep gratitude. I am Theodore, the researcher, and it has been an absolute honor to be your guide through the dark. I still notice that 71% of the individuals who find peace, comfort, and a profound sense of wonder in these quiet scientific meditations have not yet subscribed to the channel. If these gentle journeys into the infinite unknown have brought you a sense of calm and expanded your curiosity about our beautiful universe, please consider subscribing. It helps us immensely and allows us to continue unraveling the deepest, most beautiful fabrics of reality together, building a quiet community of explorers who find comfort in the cosmic dark. Now, let us take one final deep breath together and gently zoom out to view the magnificent, unified masterpiece of our shared existence. When we finally step back and view the universe not as a collection of isolated, separate objects, but as a continuous, vibrating symphony of quantum fields, our entire perspective on human life profoundly shifts. The great astrophysicist Neil deGrasse Tyson once beautifully articulated a deeply humbling scientific truth. He reminded us that we are biologically connected to every other living thing on this earth. We are chemically connected to all the molecules on this planet, and we are atomically connected to all the atoms in the vast ancient universe. We are not simply living in this universe. The universe is living entirely within us. The story of the electron is not just a dry, abstract chapter in a physics textbook. It is the intimate, physical story of your own ancient origin. The very exact electrons that are currently dancing through the complex biological networks of your brain, allowing you to hear these quiet words and ponder these deep mysteries, have been traveling for nearly 14 billion years. Think about the magnificent, epic journey of those tiny, zero-dimensional ghosts. Long before the Earth was even a swirling cloud of dust, long before our gentle sun ignited its nuclear fires, these electrons were forged in the unimaginably hot, dense crucible of the ancient cosmos. They survived the dark ages of the early universe, drifting silently through a rapidly expanding, cooling void. They were eventually pulled by the inescapable, majestic force of gravity into the crushing, chaotic hearts of the very first generation of colossal stars. Inside those ancient stellar furnaces, through the impossible magic of quantum tunneling, they participated in the brilliant, blazing fusion that created the heavier elements, the very carbon and oxygen that now gracefully build your bones and the air you breathe. And when those massive, ancient stars finally died in spectacular, violent supernova explosions, they violently scattered their precious, manufactured elements across the vast, empty canvas of the galaxy, seeding the dark interstellar clouds with the fundamental ingredients for biological life. You are the breathtaking, temporary culmination of that 14 billion-year journey. The boundary that you feel between your own physical body and the rest of the cold, distant universe is nothing more than a persistent, comforting illusion generated by your macroscopic senses. At the deepest, most fundamental quantum level, there is absolutely no strict dividing line between the atoms of your skin and the atoms of the gentle air that immediately surrounds you. There is no absolute separation between the trembling quantum fields that sustain your heartbeat and the vast, echoing fields that govern the slow, majestic rotation of the distant Andromeda galaxy. You are a localized, incredibly complex, and beautifully organized knot in the endless, shimmering web of universal energy. The quiet peace that so many of us seek in our chaotic, demanding everyday lives can be gently found by simply remembering this profound scientific truth. You are never truly alone, and you are never truly isolated, because you are physically, mathematically, and intimately woven into the very fabric of everything that has ever existed and everything that ever will exist. As we approach the end of this specific contemplation, it is absolutely vital to remember that the scientific journey is never truly finished. The story of the electron, as deeply as we have explored it, is still fundamentally incomplete. The greatest, most brilliant minds in modern theoretical physics are still working tirelessly in quiet laboratories and at massive blackboards, trying to reconcile the hazy, probabilistic world of quantum mechanics with the smooth, continuous, and heavy world of gravity described by Albert Einstein. We still do not fully understand the true, hidden nature of dark matter, the invisible scaffolding that holds the swirling galaxies together, nor do we understand the dark energy that is relentlessly tearing the cosmos apart. The universe remains a place of profound, echoing mystery. But this lingering uncertainty should never be a source of anxiety or existential dread. Instead, it is the greatest, most beautiful gift the cosmos could possibly offer us. Ignorance, when embraced with a quiet, open, and humble mind, is not a failure. It is the sacred, boundless territory of future discovery. It is the gentle invitation to keep asking questions, to keep looking deeper into the dark, and to keep marveling at the staggering complexity of nature. If we had all the final, absolute answers, the grand human adventure would simply end. The sky would become a painted, static ceiling rather than an infinite, deep ocean of possibility. The true beauty of science is that every single time we bravely open a new door in the dark, we discover a magnificent, echoing hallway, lined with 100 more closed doors, each one hiding a secret more bizarre and beautiful than the last. We are eternal students in an infinite classroom, and the curriculum is the majestic, unfolding story of reality itself. So, as you lie here in the comfortable, quiet dark, allow your racing thoughts to finally slow down and match the gentle, rhythmic hum of the unseen universe. Let go of the heavy, macroscopic worries of the day. They are nothing more than temporary ripples on the surface of a deep, ancient, and perfectly calm ocean. Focus your mind inward on the miraculous silent dance of the trillions of electrons that are beautifully, flawlessly sustaining your life in this exact moment. Feel the warm, comforting reality of your own existence, supported by the fierce independence of the Pauli exclusion principle and the delicate, sharing embrace of covalent bonds. You are a masterpiece of quantum architecture, a brilliant, temporary spark of consciousness in the vast eternal night. And when you eventually open your eyes tomorrow and step back into the bright, demanding, and seemingly solid world, I hope you carry a small piece of this quiet, subatomic night with you. When you touch a simple wooden table, remember the invisible, mathematical force fields that are fiercely pushing back against your hand. When you see a vibrant, green leaf illuminated by the morning sun, remember the tiny, quantum leaps of energy painting the world in beautiful color. And when you look up at the vast, starry sky, no longer see a cold, distant void, but rather a shimmering, interconnected web of possibility that you are intimately a part of. The universe is not a machine. It is a magnificent, ongoing event, and you are one of its most beautiful expressions. Our journey into the profound mystery of the electron ends here, but your personal exploration of the cosmos has only just begun. The universe is endlessly patient, quietly waiting for you to ask the next profound question. Thank you for walking through this beautiful, strange, and infinite dark with me. May your mind always remain curious. May your heart always find comfort in the vastness of the unknown. And may you always remember the invisible, silent magic that builds your world. Rest now, quiet explorer, and let the gentle, ancient rhythm of the quantum cosmos carry you peacefully into your dreams.